Thank you for having me today. So good afternoon, everyone. I'm Tohamy Ablgashim. I'm a research assistant at the McDonald Institute of Archaeological Research, University of Cambridge. So today I will be discussing the database for heritage management case study from Sudan. And the GIS and the in particular focus on remote sensing and legacy data and the work we do with the MAYASAM project. So I will bring the theoretical perspectives and a bit of examples of what we are doing. And I will explore how digital tools, specifically databases and GIS, are transforming how we document, manage, and protect archaeological heritage, especially in challenging contexts such as conflict zones. I will also reflect on the integration of legacy data and the use of tools like historical map or Google Earth Pro, which are central to my current work. Just to give a bit of context of what we're doing and what is the MAYASAM project. The MAYASAM project is the Mapping Africa's Endangered Archaeological Sites and Monuments. And as you can see on the map, the highlighted countries, we work in 13 different countries across the continent. We identify and map archaeological sites dated from the Paleolithic Early Stone Age to the 20th century using a combination of digitization of legacy records, remote sensing, and GIS-based techniques. We create a web-based repository of archaeological sites, monuments, and risks in the study areas using a customized version of the open source platform ARCHES. Design risk assessment and mitigation tools that will allow African archaeological heritage agencies to leverage the power of the MAYASAM ARCHES database to manage and protect their most endangered sites and monuments. Just to mention one thing here, I will be mentioning endangered sites a lot, but that's not what we're really doing. We document all the archaeological sites and monuments, not just the endangered ones. We work closely with the national authorities to develop a model for sustainable deployment of digital management of archaeological sites and monuments, linking this with enhanced provision of technical training for our African partners. So we do have partners in all the countries. We do have researchers based there. We do have collaboration agreement. We do have a collaboration agreement signed by Professor Ibrahim Musa with Income. And in the coming weeks, we're finalizing and renewing the new collaboration agreement. So heritage sites today face a wide range of threats. These include environmental pressures, such as climate change, but also human-driven factors like urban expansion, looting, and importantly, in the Sudanese context now. Yeah, so that was the map that's showing the African countries that we are working on and the objectives of the MAYASAM project. Can you see this one as well?
Yes, perfect.
Yeah. So as I was saying, this includes environment pressures such as climate change, but also human-driven factors like urban expansions, looting, and most importantly, in the Sudanese or in the African context, the conflict zones. Sites such like Mary, for example, have immense cultural and historical significance, yet they are increasingly vulnerable. So traditionally, heritage management relied heavily on physical documentation and site visits. However, in many cases, especially during conflict, this is no longer feasible. As a result, there has been a significant shift towards digital documentation and monitoring. Databases and GIS are now essential tools that allow us to preserve knowledge, monitor change, and make informed decisions, even when access to sites are restricted. So what is heritage database? Basically, it was defined and explained by different scholars, but it's a heritage. So a heritage database is essentially a structured system designed to store, manage, and organize information about archaeological and cultural heritage. Instead of scattered notebooks, reports, and archives, a database provides a centralized platform where all information can be stored in a consistent and accessible way. And this includes data about archaeological sites, artifacts, excavation, survey, condition and threat assessment, chronology, intangible heritage if found, environmental aspects, geometry, location, landowner, site description, and so on. The key advantage is that it allows for efficient retrieval, updating, and analysis of information, making it a foundational tool in modern heritage management. The purpose of heritage database goes beyond simple storage. It plays a critical role in several areas. It centralizes information, bringing together data that may otherwise be scattered across different institutions or different formats. It supports research and interpretation, allowing archaeologists to analyze patterns, compare sites, and develop new insights. It informs decision making. For example, heritage authorities can use database information to prioritize conservation efforts or assess risks. It also enables long-term monitoring, allowing us to track changes in the site condition over time. And finally, it facilitates collaboration, particularly in international projects like MAYASAM, for example, where multiple teams contribute to a shared data set. So the structure of heritage database, it differ. It could be different from a project to another, from a different platform to another platform. But it has evolved significantly over time, reflecting broader changes in digital archaeology and heritage management. Traditionally, many heritage databases were retrievally simple and isolated systems. They often consisted of spreadsheets or fixed tables designed primarily for storage rather than analysis. These systems usually continue text-based records with limited ability to connect related information. For example, site descriptions, excavation records, and artifact inventories might exist separately without meaningful relationships between them. Special information was also frequently absent or fully integrated, which is the structure of database builds on open time. So it's a long process. It's not something you can do that easy. Today, most systems are built using relational database structures where different types of information are linked together through relationships. For example, a site record can be connected to excavation season. Excavation can be connected to artifacts. Artifacts can be associated with photograph, drawings, or analysis, any analytical reports. This creates a much richer and more flexible system for managing archaeological information. Another major development in the integration of is the integration of spatial data. Modern heritage databases are often designed to work directly with GIS platforms, allowing each record to be linked to geographic coordinates and spatial layers. Equally important is the use of standardized vocabularies, and we call this thesaurus, and metadata frameworks, which improve consistency between projects and institutions. In project like MESAM, this shift is particularly important because we're integrating data from different countries, different record traditions, and historical periods into a unified digital framework. So the transition from traditional to modern databases is not simply technological. It represents a broad shift from passive storage towards integrated, analytical, and collaborative heritage management system. So what is legacy data? In this case, to document archaeological sites, within our projects, for example, we rely on remote sensing and legacy data. So legacy data is the material we gather from existing sources about the location and function of archaeological sites. Sources include everything from archaeological surveys to project reports authored by credible and experienced professionals. So in this diagram, you can see basically the published article here. For example, we're taking the PhD thesis of Professor Ibrahim Musa, and then we extract the data into spreadsheet, and extracting the data will any relevant plans and maps, images, any kind of information you can find about a particular archaeological site, you need it because it will help at some point. And then the location database, which will be verified using different platforms, GIS or Google Earth Pro. And the documentation noting exact procedure and using different or other satellite imageries sources. And then all the maps will be georeferenced or overlaid just to make sure that we have the exact location. And then during all this process, there will be lots of auditing activities. And then finally, it will be transformed to ARCHIS, the database platform. And you can see also the centralized spreadsheet we have with specific headings that we've been building over time, as it's the case in any database. So why legacy data matters? Legacy data is not secondary, it's foundational for any databases. In many cases, it represents the only surviving records of sites that are now damaged or inaccessible. In places like Sudan, for example, field work is often impossible in some part of the country. This means that archival data becomes the primary source of information. For example, if a site is damaged today, legacy documentation allows us to reconstruct its previous condition. It also enables long-term analysis, such as tracking changes in site conditions. settlement patterns and or environmental impacts over decades. Importantly, integrating legacy data ensures that early archaeological work, often conducted under difficult conditions, so it's not lost or overlooked. It brings historical research into modern and analytical framework. There's lots of challenges with legacy data, and it's actually one of the biggest challenges in heritage management, particularly in African context. Much of the archaeological work conducted over the past century, especially during the colonial era, early post-colonial periods as well, was recorded in non-digital formats. So everything is on paper. This includes handwritten notebooks, printed reports, sketch maps, and photographic archives. A key issue is inconsistency in terminology. For example, the same site might be described differently depending on the researcher, the language, or the period. I'm sure that most of you have seen this before. Sites like Mary, for example, is being written in a lot of different ways, such Jebel Barkal, Jebel Barkal, Jebel Barkal, or just Barkal. So yes, it's different from authors to another authors. The language barrier is also a big thing. Terms like settlement, mound, or habitation sites may not align across datasets. This creates difficulties when trying to unify records into a single database. Another major issue is lack of precise spatial data. Many older records refer to locations descriptively, such as 2 kilometers north of Khartoum or 2 kilometers north of the Nile. How can you find that site? It's almost impossible without coordinates. So this makes it difficult to relocate or map sites accurately. Data is often fragmented across institutions, museums, and universities, unpublished archives, and even personal collections. In Sudan, for example, data relating to sites like Mary may exist across multiple countries and institutions. Finally, there is a serious risk of data loss, especially in conflict situations. Archives can be damaged as well, looted, or destroyed, making digitization and integration urgent priorities. So integrating legacy data is not simply about digitizing old records. It's complex, multi-step, intellectual, and technical process. The first step is, of course, digitizing, which includes scanning documents, transcribing handwritten notes, and converting analog photographs into digital formats. However, digitization alone cannot make sense without data usable, without metadata. Next comes data cleaning and validation. This involves correcting errors and removing duplicates and ensuring consistency. For example, site names may appear in multiple spellings due to the translation from Arabic or another language. This needs to be standardized. A crucial step is terminology standardization. So in the MySAM project, this is particularly important because we are working across different countries in Africa and different traditions of recording, describing, and so on. So establishing controlled vocabularies ensures that data can be compared and queried effectively. One of the most challenging aspects as well is georeferencing. For sites without coordinates, we reconstruct their location using the descriptions from the reports, the historical maps, the satellite imagery, the local knowledge, well, if it's available. And this process often involves interpretation and uncertainty, which must be documented transparently. Finally, the cleaned and standardized data is integrated into a structured database where relationships between sites, surveys, and finds can be established. In our work, particularly in Sudan, this process is not just technical, it's also about recovering archaeological knowledge that may otherwise be lost. And we do have lots of examples from different areas in Sudan where archaeological sites are no longer exist. We can see it on papers, but you can't really see it on the satellite imagery or on the ground anymore. So, so how GIS integrates with heritage data and what is GIS? I'm sure you guys have got some lectures before about GIS and remote sensing and so on, but basically GIS is more than just mapping. It's a system for managing, analyzing, and visualizing spatial relationships. In heritage management, GIS allows us to link each archaeological record in a database to a geographic location. This transforms static data into something dynamic and interactive. So, for example, instead of simply listing sites, we can visualize their distribution. We can analyze proximity to environmental features like rivers, for example, identify patterns in settlement or land use, land cover. This spatial dimension is essentially for understanding archaeological landscape, not just individual sites. So this is an example of one of the sources we used with the Mayan project. It's archival work in Darfur, and it was published in Sudan Notes and Records. So as you can see, this map was taken. It was georeferenced using GIS, and all the sites he visited or he marked, it was documented. And he also shared some photos of the enclosures he had visited there. Another source we used is Professor Ibrahim Musa thesis, the archaeology of Central Darfur in the last in the first millennium, and then yeah, so I have worked on this source particularly, and he was able to identify and work in lots of different archaeological sites. I will show later some of his work as an example. This is also an example of legacy data from the fifth cataract, so it's all connected to what we're doing. The map to the left, we'll come to it later, but the one to the right, the top right, it's a legacy data. A survey was conducted in the River Nile state by Frederica Jesse. So we used her data as a base, And then we laid out grids in the same area where we were able to document using remote sensing. We were able to document over 1,900 sites in the same area, as you can see on the map on the left. So working with historical maps, it's our historical maps are an extremely important resource in archaeological and heritage research, especially in regions where modern surveys are incomplete or where landscapes have changed significantly over time. Um, the types of maps we use vary considerably. This includes colonial survey maps, to topographic maps, military maps, administrative and cadastral maps, early expedition sketch maps, historical and aerial photographs. It's an important point in that many of those maps were colonial maps and were not originally designed to trace or to record archaeological sites. The primary purpose was often administrative or military or economic, but we still, despite this, they remain highly valuable for archaeology because they often record landscapes and features that have since disappeared or changed. So within GIS workflow, these maps are first georeferenced, meaning they are aligned with modern coordinate systems. This process involves matching identifiable features such as river bends, hills, settlements with current satellite imagery. So we do have lots of, I mean, not a lot of it, and in the African continent, but there are some from the British military, and we can find it here in the British archive or at the University of Durham, where we were able to georeference and document lots of different archaeological sites. So these are the types of the historical maps, the topographic maps, the 1 to 250 series of Sudan, the regional historical maps, the David Ramsey collection. It's a very famous collection. And then this is the first-hand account. So those are the types of maps that are available and the type of maps that we're working with in like daily basis. And so as I mentioned before, it's the purpose of those maps were not to trace or to document archaeological sites, but we were lucky in a lot of, in different times where there will be noted something like Gubba, for example, referring to a modern Gubba or an archaeological site. We will find a sign of a church and so on. So this is also the examples of how we see the graves from the top, the graves on the top left, the graves on the historical maps, and down the graves on the satellite imagery, and then down how we see it on the ground, tumuli or cairns. The one in the middle as well, the ancient fort, that's how you see it on the historical map. And then in the middle, the satellite imagery, and then that's how it looks from the ground. The same thing for the cemetery, the box grave cemetery, and the mosque. So as I mentioned before, we rely heavily on using Google Earth for heritage management. And in addition to GIS platforms, we make extensive use of Google Earth. Its historical imagery features allow us to track changes over time, making it particularly valuable for monitoring site conditions and threat assessment as well. So there is a specific tool that takes you through the time on Google Earth Pro. So you can track basically to 1985 or early 2000s. The early 2000s are the one that we usually use. During my work here, there was lots of sites that you can see, for example, in 2002 on the satellite imagery, but in the 2023, for example, it's no longer exist. So in Sudan, it's an essential tool for remote observation, especially when field access is not possible. It also plays an important role in training and accessibility to its widespread availability. So how did we go from the original analog map to the satellite imagery using Google Earth Pro and GIS? So I will take an example of Jebel Mal. It's been worked or documented by Professor Ibrahim Musa in his thesis. So this is the kind of information we extract using the published records. As you can see, there are coordinates, likely, and there is a description of the location of the site. So I'm not sure if this video will work. I think it will. So here, for example, we're using Google Earth Pro. We type in the coordinates, and this is actually, I'm just showing one of the challenges that we may face using published sources. So the coordinates will take us to this area where you can see there's a lot of archaeological sites. It's in the middle, on top of a mountain, which is part of the Tagabu Hills or Tagabu Range. So it's not that accurate, but we know where exactly it is. So as you can see, those are different features, different enclosures. So to this side, you can see there's lots of archaeology here, lots of enclosures. So at that point, when I was working on it, I thought, okay, this is the Jebel Mao area, which it is the Jebel Mao, but this is not the zones that he worked on. So eventually, using all the description and the other maps he provided, we came to the conclusion that this is the area where he worked. Those are the 5 zones he documented on in Jebel Mao. So as you can see, where the coordinates took us, and where eventually we verified the 5 zones that he mentioned in his book. Okay, so this is how we process the coordinates later on. As you can see from the left, this is the original coordinates extracted from the book, and to the right, this is where eventually we were able to verify where the actual sites are. This is one of his maps he provided in the book. So this is some sort of overlaying, not particularly georeferencing, because georeferencing will need more time and techniques, and some of the maps you cannot georeference in QGIS, but luckily you can overlay in Google Earth Pro. Another tool that's really important that we're currently using to monitor heritage sites is the Google Earth engine. And the Google Earth engine represents a more advanced approach to heritage monitoring. Google Earth engine is a cloud-based platform that provides access to vast archives of satellite imagery, including datasets such as Landsat and Sentinel. Unlike traditional GIS, it allows us to process and analyze large amounts of data without needing high performance local computers. One of its key strengths is time series analysis. This enables us to track change in landscapes over time, which is particularly useful for identifying gradual or sudden impacts on heritage sites. For example, we can monitor expansion of agricultural land, urban encouragement, changes in vegetation cover, signs of site disturbance or looting. Another important aspect is the ability to automate analysis using scripts. We can detect patterns of anomalies across large regions, making it possible to monitor hundreds or even thousands of sites continuously. In the context of Sudan, this is especially valuable given the scale of the country and the limitation of field access. Google Earth Engine allow us to continuous large-scale observation of heritage landscape. It also complements tools like Google Earth Pro and QGIS by adding a powerful analytical layers focused on temporal and regional changes. So overall, it represents a shift from side-by-side analysis to landscape scale monitoring, which is increasingly important in heritage management. So this is some examples. From the left, you can see the agricultural expansion near Dongola, intensification. And to the right, you can see mining activity in the Fifth Cataract. So you can see there are two different photos shifting from the 2005 to 2020. So you can see the difference between the two pictures, where some of the sites are no longer visible because of the gold mining. Finally, just to speak a little bit of the database platform itself. So we use ArcGIS databases. It's relatively new, but it's been used for the past decade, I think, by different projects, similar to what we're doing now. Started with the MENA project, for example, the University of Oxford. They were working in the Middle East and Northern Africa, and then MASA project, sister project to ours at the University of Cambridge. They work in South Asia, India, and Pakistan. So ArcGIS is an open source software platform for cultural heritage data management, developed jointly by the Getty Conservation Institute and World Monument Fund. So what makes it very valuable? So there are key benefits of using ArcGIS database. There is a map centered interface to display and manage the data, a local search engine to index the database quickly and efficiently, built-in security features that enable multiple levels of access to the data. So unlike traditional structured database, Archis uses graph database mechanism in the form of resource models. The complexity of the archaeological data is preserved in a cascading structure of nodes and relationships. Information is encoded in a systematically aware design. Archie supports the use of ACOM's CDOC CRM, and this is another topic for the creation of resource models via ontological concepts derived from data to ensure controlled terminology. So that's it for me for today. If you would like to read more about the project and what we're doing and about databases in heritage management, you can visit the MASAM, the Mapping Africa's Endangered Archaeological Sites and Monuments website, and also through the social media platforms. Thank you to you all today for listening to me and to the Arcadia Fund, the funders of the MASAM project, and all the MASAM team, the Irkoni project, and the ALIPH Foundation.